Hey gang, so what I want to do in this video is take the conversations that we've been having about motion and go into the concept of acceleration. Now when we do that, here are some of the big ideas. I want to review the idea of velocity. I want to talk about how acceleration is the rate of change in velocity, and then give you some examples of me in high school and the car that I had and the car that I wish I had. Now, just in typical SpencerPhysics fashion, I've got a little video for you to kind of think about what we're talking about with acceleration.
Oh, wow.
Yeah, nice and easy. You'll just head on out and whenever you're ready.
Are you ready to go ahead and drive? Okay.
Yeah, sure.
Oh, whoa.
That's all right.
A little more than I'm used to.
Yeah. It's got some power, so just get a feel for it. Okay. Okay, all right. Ease off just a little. Ease off.
So I was thinking a little more age on me, some wrinkles, a little dorky, maybe some facial hair. It was somebody that I can pull off a fun prank with. Let's go have some fun. My good friends at Pepsi Max have hooked us up with this cool cam. So these are the glasses cam that show you everything that I see.
How you doing?
Hello. I'm Mike.
Steve, nice to meet you, Mike. I saw you sort of gravitated towards the Camaro. You thinking about getting one?
Oh, no. This way too much car for me.
Well, it's a lot of power, but they designed it to be very safe.
I don't know if I can handle it. I've never driven anything like this before.
Well, I tell you what, I think a way to really make you feel comfortable would be to put you behind the wheel.
You're good.
What are you driving now?
Oh, just a minivan.
Oh, yeah.
What am I
You're not
signing
obligated.
here? Sure?
It's just a checkout sheet for a test drive. You're not obligated to anything. It's just so we know who's out. Let's go give it a drive.
I'm getting a little nervous.
No, I'll be right there beside you. There are your keys, sir.
Thank you, Steve.
You'll have to unlock it, Mike.
Oh,
Yeah.
thank you.
There we go.
Oh, yeah. What a car.
Mm-hmm.
Well, we better buckle up.
Yeah, good call. Yeah. Power door locks, standard, of course.
You are liable for any damages to the vehicle, so please stop the car, or at least slow down. Slow down. Slow down. You can't go through that gate, Mike. Stop! Stop! I'm gonna get you. Stop!
All right, so with that in mind, let's just go over some things that we've already talked about. Now remember, velocity is a vector, okay? We've talked about vectors and scalars. We've talked about how scalars are just kind of magnitude, how much. But with vectors, you have not only magnitude, but you also have direction. So if you're still having a hard time trying to remember this whole idea of the difference between vector and scalar, check this out.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
So remember, with velocity being a vector and having both magnitude and direction, the way that you can change the velocity of an object is done by either changing its speed or changing its direction. So think about this. If you're in a car, you change the speed, well, you speed up by hitting the gas pedal, okay? You slow down by hitting the brake. But remember, you can also change the velocity by changing the direction. So that would be your steering wheel there. But let's kind of talk about what this has to do with acceleration, because what acceleration is acceleration is the rate of change in the velocity of an object. So it's how fast something is speeding up or slowing down. So if I'm speeding up, I have positive acceleration. If I'm slowing down, I have negative acceleration. But if I have constant velocity, and remember, I can have constant velocity by either not moving or just moving at the same speed without that changing, then I have zero acceleration. So let's kind of take you back a little trip down memory lane. 1991, I was in high school. Right around then, I finally got my driver's license. Finally was able to go out and terrorize the world by driving around. And the very first car I got was a 1991 Ford Festiva. Now, this baby was a piece of engineering genius. It looked like a roller skate. It was really small, but the great thing about it was that it would get like 40 miles to the gallon on highway in like 35 city or whatever there. Now, the only problem is this thing had amazing gas mileage. But it had no pickup at all. In fact, we found that when you got on the highway and right around 55 miles an hour, the steering wheel would start shaking, and you had to kind of get behind semis and draft off of them, which when you're in a small car like that is a really stupid idea. So yeah, that was my first car. I survived. But here's the thing. The one thing that I hated about this car was that when I would hit the gas, nothing would happen. I'd try to accelerate, I'd try to speed up, and I'd hit down on the gas, and it would just think about it for a while and then slowly start to speed up. And if you're a car person at all, like one of the big indicators of how powerful a car is what's called 0 to 60 and how much time. So in other words, how much time does it take to go from standing still to 60 miles an hour? And we figured that it took about 15 seconds for this little Ford Festiva to go from 0 to 60. Now compare that to the car that I wish I had. I wanted a Mustang more than anything. And now this is a picture of the very first Mustang. This is over at Henry Ford Museum out in the Detroit area. Now this thing has some power to it. Now when you just tap the gas on a Mustang, it takes off. So it's much more powerful than my Festiva. So if you're looking at this and doing the whole 0 to 60 thing, for this particular Mustang, 0 to 60, you could do 0 to 60 in about 6.7 seconds. So it would speed up a lot faster than the Ford Festiva that I had. So let's kind of think about what this has to do with acceleration. So acceleration is a rate. So it's a change in something over a time interval. And acceleration is this idea of the change in speed per unit of time. Another way of looking at this is right down here at the bottom. You have acceleration equaling delta v divided by delta t. Now that triangle right there, that's the symbol for delta, and it means change in. So delta v means the change in velocity. Delta t means the change in time. So one way of looking at that is by saying, okay, this is the velocity that I was at the end. This is the velocity that I was at the beginning. The change in that is just taking the final velocity minus the initial velocity and finding out what that is. Same idea with the time. Now, if we go and find the acceleration of these two cars, so look up there towards the top with the Festiva. Delta V of the Festiva, so the change in velocity. So if I'm going from 0 to 60 miles an hour, well, the initial velocity and the initial time are both 0, so we can just get rid of those. Final velocity is 60 miles per hour, and the final time is 15 seconds. It took me 15 seconds to get up to 60 miles an hour. So if I go and calculate the acceleration, we've got 60 miles per hour divided by 15 seconds. So that's going to go and equal about 4, but then we've got the units, okay? So if I take miles per hour and divide that by seconds, I've got miles per hour per second. In other words, what this is telling me is that for every second, the Festiva, its velocity would increase by 4 miles per hour. Now, if we take a look at the Mustang, same idea. Acceleration is the change in velocity over change in time, so delta v divided by delta t. And remember, from 0 to 60, the change in velocity is still the same. We're going up to 60 miles an hour, but the speed, the amount of time it took to do that, is much faster for the Mustang because it's a more powerful engine. So if I do the math on that, it's about 9 miles per hour per second. So that means that if I'm in a Mustang, every second the velocity will increase by 9 miles per hour. So let's compare both the accelerations of the Ford Festiva as well as the Ford Mustang. So remember, the acceleration from 0 to 60 for my Festiva was 4 miles per hour per second. So in other words, every second, the velocity is going to increase by 4 miles per hour. So at time, if I'm going from a standstill, after 1 second, I'm going to have a speed of 4 miles per hour. After 2 seconds, I'm going to have a speed of 8 miles per hour. After 3 seconds, I'm going to have a speed of 12 miles per hour. And it's going to take me 15 seconds to finally get up to 60 miles per hour. But if we look at the Mustang, okay, that has a much more powerful engine. That has a much greater acceleration. So there, if I'm going from a standstill, because it accelerates so much faster, after 1 second, it's going 9 miles per hour, which would take the Festiva more than 2 seconds to do. After 2 seconds for the Mustang, it's going to be at 18 miles per hour. After 3 seconds, it's going to be at 27. So, and in fact, after about 9 seconds, give or take, it's going to be at 60. So it is able to get up to that speed, 60 miles per hour, much faster than the Festiva could. So hopefully that is a good introduction to you on the concept of acceleration. So just to kind of recap things, we talked about the idea that velocity is a vector. We can change velocity by either changing the speed or changing the direction. We know that acceleration is the rate that the velocity of an object changes. So in this case, we talked about miles per hour per second. We'll talk more later about some different units for that. And then the whole idea is that you can calculate acceleration by doing the change in velocity divided by the elapsed time, or the change in time. So hopefully that helps. If you have any questions, let me know.